Hi Ian, how's it going?
Brian, how are you?
Not too bad, sir. How you doing?
Good, good.
Very cool. All right, we got more people coming through. That's good.
Nice, nice.
Yeah, thanks again for doing this. Very
Oh,
happy
of
that
course.
you decided to do this. So, actually, at my job, we're starting to use Databricks and MLflow. So it's actually like a cool
Yeah.
little yeah.
Is this your new job you said, right?
Yeah. So currently, like we're like a lot of people are using like MLflow, like Databricks, and it's a new thing for me too. So
Yeah, yeah. This is at M&T, right? You said, I think.
yeah.
Does that mean you're in Buffalo? Or
No, I'm in Bridgeport, Connecticut. So I'm like
oh,
in
okay,
Connecticut,
okay.
but yeah,
Gotcha, gotcha. I know they have a big headquarters there, and that's close to where we are, so
oh,
just
very
didn't know
cool.
if you were there. Yeah, that's cool though.
All right, so let's start the webinar. I think we're in a practice session.
Oh,
All right, all right. Uh, so everybody, hey, thanks for coming through. I think there's some more people showing up. We just started. Uh, We're just starting up the Bayesian data analysis meetup again. I've done sort of meetups in the past. I think more in person, so we'll try to do more of that in the beginning of the year. We just want to get this started with like some virtual events first. Um, you know, Thanks again, Ian, for doing this. He's at Wegmans, grocery store chain, I think, right? Um, do you want to just give a bit of intro about yourself and just introduce yourself to everybody?
yeah, sure. So, my name's Ian. I'm a data scientist at Wegmans Food Markets. Been there for the last 6, almost 7 years now, and yeah, do a lot of base stuff when I can.
Very cool, sir. All right, yeah, and I think today we're going to talk about Bayesian models in production. So I was just talking to Ian. I'm somebody who's new to like using MLflow and Databricks and sort of like kind of doing things that way. Um, Ian, I'll kind of give you the reins just to take over a bit and just you can talk about sort of what you want to present on and share your screen. If you have like slides, let me know.
Yeah, definitely. This is not a Gelman style presentation where it's just, you know,
Yeah.
I'm not that level of.
No, it's all right, man.
I just need to figure out how to share my screen quick because Zoom. 2 seconds.
Yeah, let me know if you have
Okay,
any
so
issues.
looks like I have to send a request to you to
Yeah.
share my screen.
Yeah, you can do that.
Sweet. Okay, awesome. Can you uh can you see that, Brian?
Yeah, I can see that.
Okay, awesome. 1 second. Okay. Oh, and I even get my laser pointer too. Can you see that?
Yeah, I can see that.
Okay, that'll come in handy. Okay, cool. Let's move this out of the way. Okay. So, thanks everyone for coming out, and thanks Brian for putting this together. Hope everyone get something out of it. Feel free to, I don't know how you want to work it, Brian, but drop questions and I can answer them along the way so no one gets lost. Um, when I first saw the post from Brian about, does anyone have anything to say about Bayesian models in production? It was kind of a little bit of serendipity because I remember 5 years ago I was at a conference, and at that conference there was a person up front, and they were given this great talk from the USDA about all the great stuff they're doing. And one of the things that the presenter just kind of said in passing was, "Yeah, we have these Bayesian models and they're in production, right?" And young me, raised his hand in a room full of people much smarter than him and asked the question, how do you get Bayesian models in production? And felt like everyone in the crowd just kind of leaned in and was like waiting on her to answer. Because I think it is something that a lot of people do have questions about, right? It feels a little bit, how do you navigate this world? Because half of it's academic and then the other half is this, MLOps thing. Suffice to say, I think she was thrown off. She didn't really get to answer my question. So here we are 5 years later, and I'm answering it now. So um, let's keep going. So just a brief outline. First, I do want to just introduce Wegmans and put a context around things, and why we feel like we get a lot out of using Bayes. Second, we're going to do a little bit of like an MLOps kind of run through. Won't be exhaustive, but I think it's the things that make the most sense for this context. And then last, probably the most fun will be the examples in practice. So, of course, if you have questions along the way, just shout. So, what is a Wegmans? So, raise your hand if you know what a Wegmans is. One, two, three. I'm kidding. I can't see on the Zoom, but I'm hoping there's a lot of hands. Oh, thank you, Brian. I'm assuming there's a lot of hands up there. For those of you that don't know, we're a regional grocery store in the East Coast. We have about 114 stores, a little over 54,000 employees. Relatively large. We pride ourselves on our quality, but also how we serve our customers, right? The cleanliness of our stores. We just want to make it the best experience possible. And I think that really resonates with a lot of our customers. But why Bayes? And I know for this talk, right, it's a little bit like why, I'm telling fish how great water is, but just stick with me. I feel like we all got to do it when we talk about Bayes. I think for Wegmans, one of the things that's so important for us, and I'm sure a lot of you can relate, is the tribal knowledge that's baked into the organization. I think it'd be very hard to throw a stone and not hit somebody that has been with the company for more than 40 years. So there's a lot of people that have worked there from when they were cashiers on the front end to wherever they are today in their very long career. So the amount of knowledge that these employees have and can bring to the table is amazing, right? So you can have these very high level conversations about the structure of the model and all that. And, we as Bayesians know that we can build our Legos and turn that Bayesian crank and we get exactly what we want, no strings attached, right? And that's why I love it so much. That's why I kind of fell in love with this framework. Um, in line with that, right, you get to build the model that you want, especially, and the business wants, right? So there's this great collaboration that can take place, and not just with prior elicitation, right? We all hear that, but it's more than that, right? It's the model structure itself. And then last, at least the way I see it, is you can always get simpler interpretations, and it's easier to communicate between technical and non-technical people. Um, all right, so production model basics. Again, this is not an exhaustive list. This is just the kind of topics that I want to cover at a high level. There's so many things that I wish I had time for, but this is a hour-long presentation and not 4 hours. So, or else this would be much longer. The first thing that I think everyone thinks about when they go, well, how do you put Bayesian models in production? Is probably parameterization and inference, right? That's at the heart of what we do. And the topics that I want to cover here, and it's a bit of an eye chart, but we're going to step through it step by step, right? Number one, hands down, got to be Mr. QR decomposition. So for those of you that aren't familiar with the QR decomp, haven't seen the light, this is a matrix factorization method, right, where you take your model matrix X. So oh, good, my laser pointer's working. Your model matrix X, decompose it into two matrices Q and R, right, where Q is an orthogonal matrix. And now instead of naively multiplying X and beta, you now do Q post multiply beta prime. And now because of that, the parameter space for beta prime so much better behaved. And then of course you can always recover it by pre-multiplying by the R inverse. It feels like magic. It is a little bit of magic the first couple of times, but it's just, one of those things that I'm always doing, because even if there's a little bit of correlation in your data, it's almost always better to just do this little bit of a front calculation, because you only do it once. You don't do it during all your sampling steps, right? You only do it once, and then bam, huge payoff. So your model will thank you later, as with a lot of these things. The next one, I feel like it's almost silly to bring up, but I think the gains from it are so large, I just couldn't not bring it up, and that is covariate standardization, which we all hear about and are taught to do in our first semester classes. But I'd be remiss if I didn't bring it up again because this really does help your posterior geometries, especially when you have covariates that are on wildly different scales, right? So for me, I might have covariate A that is in millions of dollars, right? And then covariate 2, which is in square footage, right? And you wouldn't believe the speed up you get by taking your millions of dollars, dividing it by 1/6, and then your square footage and dividing it by like 1/5, right? Puts it on the same scale. It still means the same thing, right? I can always recover that because that's the best part about working with samples, right? Is I don't have to worry about uncertainty propagation and all that. But the push through, right, to get it these great inferences and how fast the speed up you get is phenomenal. The next one, again, I feel like everyone knows this, but I got to touch on it because it's so huge and it's so great. And that's of course our non-centered versus centered parameterization trade-off. For those of you that aren't familiar, right? Let's say that I want to model the contribution of a customer's behavior given the state that they're living in, right? I might want to share information across states, right? Someone that's living in New York might be someone to one in PA, so on and so forth, right? I don't want to model those as like discrete uh, variables. So what I'll do is I'll set up a hierarchical model, right? And I'm sure everyone is familiar, right? As we try to do the naive centered approach where I have, a mu and a sigma. As the model learns sigma and it gets smaller, that's going to constrain mu, and you get your funnel, which everyone hates. It's the dreaded funnel, right? The solution, of course, is to decouple those, where you have z as the standard normal, bam, multiplied by your sigma and add in your mu, and everyone's happy. Um, Again, huge speed ups, right? For the cases where it really matters, this can be just slim, easy pickings, right? Of course, in the high data regime, the large n regime, the center does become favor because the likelihood function kind of overtakes your posterior geometry. But because the non-centered is so robust, I almost just always recommend it. That's my default, unless I need to switch and do some sort of partially centered parameterization.
Um,
Um,
one quick
yeah,
question.
yeah.
So I think Robbie B asks, why do you need a Bayesian model? What are you modeling or simulating? Customer behavior. What are you applying the Bayesian model to?
Oh, great question. I think I can speak to it a little bit right now, but we have some examples at the end that I think will really solidify it. We're going to go through some
Gotcha.
very practical examples. At a high level, we fall in love with it at the company as a modeling framework because it is so customizable, right? I kind of alluded to it before where I said, working with Bayesian models is like working with Legos, right? You can kind of build this piece and do this little stud here and you build the model you want. You're not at the mercy of whatever MLE algorithm has been designed for you. You can do whatever you want. And that's kind of why I fall in love with it amongst other things. But again, great question. We're going to kind of come to it at the end where I have three examples of Bayesian models in production. Oh, good
Very
question.
cool. Yeah, I think
Um,
that's it for now. You can continue. Sorry about that.
no, you're good. I love questions.
All right.
Um,
Yeah.
So the next one, we're going to start getting a little codey, right? This is not a math notation presentation. This is a practical presentation, so there'll be a little bit of code, but even if you don't understand it, you should be able to follow along and kind of understand the sentiment. Um, this first one is, of course, more stand focused, and this is beat into us as the beginning stand programmers. But it's always good to remind ourselves that when we're doing any sort of likelihood calculation, log likelihood, right? It's almost always better to do this vectorization approach down here. Use that likelihood function in stand right out rather than looping over. And it sounds silly, it sounds naive, but as these models start to get quite complex, and especially for like mixture models, right, where you're going to have to iterate over in some degree, don't get caught in the rut. Don't feel like you should be doing loops and stuff like that. It's almost always better to do this this vectorization with the likelihood. Um, last, oh, not last, we got more to go. This next one is a little bit more niche in that it kind of crops up in different places, and that's aggregating your data where it makes sense, right? It's trading likelihoods for their aggregate form. A great example of this might be that you're running a survey, right? And the survey has, 3 or 4 questions, each with 5 different choices, right? And you want to model some binary outcome. Well, if you have like a million data points, right, you can of course do your, vanilla Bernoulli and call it a day, legacy regression. But it would be a lot faster if you group by those like terms in your covariates, right? And instead of started counting the cases where you get positives rather than modeling each individual case because you're just duplicating data. And I think, we always see this in that Bernoulli binomial context, but you can, of course, do that with a normal likelihood and a Poisson as well. So when that becomes available to you, again, especially if you're doing survey data modeling, this is huge speed ups when you're collecting lots and lots of data. And if you got a lot of models to fit over and over again, it just gets, yeah, better and better. This is a new one. This is the reduce sum function in Stan. Again, more Stan focused, not so much PyMC. We'll get to my PyMC folks a little bit later. But this one comes to us because it's almost always better to ask the CPU to do the parallelization for you, right? If you have the ability to do any sort of parallelization, ask the CPU to do it. And what I mean by that is if you look at this Bernoulli logic, what's really going on under the hood is just a bunch of summations over log likelihood calculations, right? And if I'm doing that one after another, obviously it's a lot faster to just parallelize those log likelihood summations. And that's all reduced sum is doing for you. It's just parallelizing those log likelihood calculations. A lot of tongue twisters. And it's just as simple as defining a function that sits on top of whatever likelihood function you want and saying, all right, here's my covariates. You can slice and dice it however you want, Mr. Stan, and add up those log likelihood terms however you want, and you get huge speed ups by just doing something this simple. And of course, all these things stack, right? All these speed ups, these parameterization tricks I've been talking about, they stack very well. So I want to do a quick example where we kind of show how that would look like in real life. So there's a lot of code. You don't have to understand it. It's really there. So if I share it later, you guys can rerun it. What it's pulling for me is a matrix X that has high degrees of correlation. There's our friendly friend, the row, our matrix X, and then some sort of 0, 1 target variable, right? Super simple. Just X, then Y. If you were to naively model this with your simple GLM with, again, it's 500,000 data points. It's not small. This is big data stuff, right? That would take around 14 minutes. So some of you are jumping up and down with joy because I've seen the stand forms and some people are waiting 6 hours for things to converge, and this might be good enough for you, but we can do better. If we do our QR decomposition on that X matrix, it actually goes down to just under 9 minutes, which is already amazing, right? These things are not linear. This is going to get better as you get more data, as you get more correlations in there. They just stack. The magic keeps going. All right. And then the last one here is the reduced sum on top of that. So with the QR decomp, with the reduced sum, I'm now down to 6 minutes. I've cut my time more than half just based on those two very simple, less than 10 lines of code improvements. So again, at the beginning, it feels like magic, and it works a little bit like magic when you do these simple tricks. It's very cool. All right, this is another one for parameterization and inference, and it's a little bit silly, but it's just sample less. Sometimes you don't need to sample 1,000 times, right? So when you're running your samplers, when you're doing inference, right, I think the default is to always go 1,000, but sometimes you don't need that based on what you're doing. There's actually a pretty well-known quote from McKay 2003, where he says that even an effective sample size of 20 can be meaningful. And I think that kind of blows some of our minds, but it's true, right? How is it true? Well, do it for yourself. Go get that Markov chain standard error and see for yourself. Calculate your estimator, get that MCSC, and see if it is good enough for you. If you can cut down your iterations by 50, 60%, that can be a huge improvement, especially if you're fitting these models over and over again in production in any form, right? So these can be huge speed ups for honestly, you're not really using your brain that much. You're just telling the model to sample less. I think this comes up a lot when we look at histograms. So again, I know it's a bit of an eye chart, but I see this all the time whenever I'm reading anything by Michael Betancourt, right? He's always really quick to throw those MCSC errors in his histograms because, what is a histogram bin if not just a summation over an indicator function, right? That's all it is. That's all a bin is. It's the proportion of time that falls into that bin. So of course you can calculate an MCSE for that estimator, which is again the proportion that it falls into the bin. You get these error bars on your histogram that basically tell you how uncertain you are of the proportion to each group, right? So I kind of threw up here the different number of samples that have gone into the one. So this is a model with 4 chains, right? And for this histogram here, this is showing a parameter that's been sampled 20 times or 20 samples given to us from each chain. So of course, 80 samples, effective size, sample size, or effective sample size of 152. This is what that histogram looks like over here. This is the distribution we get when we sample 1,000 times per chain. So obviously the shape is a lot cleaner here, but if you're really just trying to understand the skew of the distribution, you need, 4,000 samples? Not really. 800 is more than enough, right? If you're just trying to understand if it's left skewed, right skewed. And this is kind of what I'm getting at is if you're just looking for a mean of a distribution, if you're just looking for this, just that, calculate your MCSC because it's probably pretty likely you don't need to sample as much as you think you do. All right, we're not in the world of Gibbs and Jags anymore, right? We can stop sampling because HMC is really good, really good at what it does. And then the last one that I've honestly just recently started putting into my workflow after reading a case study by Aki Vetteri, his Gaussian process case study, and that is to think more thoughtfully of your initializations, right? I kind of talked about the back end, which is the sampling iterations. This helps you with your front end, your warm up iterations, right? Determining the different parameters that your HMC algorithm needs to kind of learn in order to give you those good samples during your sampling phase, right? And that's helped by choosing good initializations. One of the kind of up and coming ones, right, is to fit your model via Pathfinder, which is just an ADVI interface, ADVI algorithm, and then you can use that fit algorithm to kind of jitter around and find good initializations, and then you can start your sampling. And this can really speed up that warm up phase, so you can get to the good stuff even faster. But again, as with all of this, right, your mileage may vary, and it's always good to inspect things and not just think blindly, right? I wouldn't recommend doing a Pathfinder initialization for a mixed model, right? That wouldn't really make any sense. You're going to have bimodality whether you like it or not. So I wouldn't recommend it there. But if you have a nice little GLM you're fitting, why not give it a shot?
Very cool.
So that's a parameterization and inference. Let's talk a little bit about data drift. So this is basic MLOps stuff, right? This is the stuff that we always need to be thinking about when we're putting models in production. Of course, I'm going to go through them in a second. Really, there's 3 main categories of quote unquote data drift, right? And we're going to walk through those in just a second. So the interpretation or the walkthrough method I'm going to use is one that is pretty popular. I think if you want to read more, you can look at Chip Quen's book. What is it called? Machine Learning Systems, something like that. There's a reference at the end if you want to dig deeper. But she basically kind of proposes that we start looking at that joint probability function of P and X and Y, right? Where X is our model matrix and Y is our target variable. And we can, of course, decompose it in a bunch of different ways, right? We can have P of X times P of Y given X, or P of Y times P of X given Y. Covariate shift is when that P of X distribution changes, but our P of Y given X is constant. So that relationship between X and Y is changing, but X itself, or I'm sorry, the relationship between X and Y is constant, but the distribution of X is changing. Um, from my world, this would happen if a mapping between items changes without an analyst knowing. So, like if yogurt, for instance, always lived under dairy and now, whoop, it's over in cold cuts, right? This happens. This is a real example. This happens sometimes, right? Of course, that distribution of data is going to change for dairy because it no longer has some of its SKUs in it, right? So that's an example of covariate shift. Label shift, that's when P of Y changes, but P of X given Y is constant. Again, the relationship between your target and your covariate hasn't changed. It's just the target variable itself that is changing in distribution. So this might be a new influx of customers to our market that are behaving differently, right? So let's say that I have a bunch of people that are now, under 30 and are deciding they love Wegmans, and I love that, and they love Wegmans and they want to shop more and more. Of course, that's going to change the distribution of my target variable, but I already know what those customers look like from a quote unquote customer segmentation perspective. That relationship between X and Y isn't changing. And then the last one, which is scariest, right? This is the one we hate to see, and that's concept drift. That's when the relationship between X and Y is now changing. X is staying constant, but what how Y learns from X is changing. So this might be, healthy customers start purchasing unhealthy items, right? So the model had learned that these quote unquote unhealthy items mean that a customer is quote unquote unhealthy, but if everyone starts buying them, that's going to change the relationship. Example, right? This is real stuff. This happens every day, whether I like it or not. And this is two different KDE plots from a model run, right? So this is a model where we've run it twice and we've plotted the distribution of X, and boom, they live right on top of each other, right? But this is the relationship between Y and X. This is what the model learns, right? And what we're noticing between runs is that there's this huge difference, right? And you can detect it however you want. If you're a fan of the kale divergence, go right ahead. If you're more of a topology guy, go for your Fisher Rao. I don't care, whatever you want, right? But you can detect that, right? You can see that. So an example of this might be that, and this happens all the time, a TikTok trend comes out and everyone starts buying this one product. Doesn't matter if you're young, old, doesn't matter. And that, of course, is going to change the concept drift for the distribution because the relationship between Y and X is now diluted. So that happens all the time. And then it's no big deal. We catch it and we refit our models and we rethink about that relationship. But we have to be monitoring it in order to catch it. If you're not monitoring it, it's just happening in the background and you're sending bad data to marketing and you get a nasty email in the morning. So what do we monitor? Data drift and everything else. Monitor whatever you want. And as Brian kind of alluded to at the beginning, this is a great opportunity to introduce the star of the show, Mr. MLFlow. So it's really MLFlow's world, and we're all just living in it. I get a lot of use out of it, and I think it's a great API, great program, great interface, whatever you want to call it. It can do a lot of things. MLFlow can track data drift. It can track models. It can track training and testing parameters. It can track even data or diagnostic plots, right? This guy can do it all. He just does not stop. So highly recommend starting to use MLFlow. And we are going to walk through an example right after this, showing how MLFlow would look like in a test workflow, right? To show that it's not as scary, right? Everyone can do it. Everyone should be doing it. It's very easy to do. So we're going to do a little bit of coding. Hope everyone's okay. Hope everyone's fingers are warm. So this is how MLFlow works. It's very simple. It's very, well, quote unquote simple compared to all the other crazy models you guys are fitting. It's easy to set up and it's easy to start going. So the first thing we have to do is define an experiment. This is really just a directory where you want to house all these files that we're about to start collecting, right? And then we start a context. This is a little bit of Python code, but you can do it in R or whatever you want. And you basically tell MLFlow, all right, start tracking for me, kid. And what do we track? Again, anything we want, whatever your heart desires. So you can log parameters, right? This is telling MLFlow, hey, go ahead and see how many training points we have, how many testing points we have. Commit this to your directory. We can then go ahead and, this is where my PyMC fans start to shout. You can fit your PyMC model, get your iData sample. If you're doing scan, of course, you can do the same thing. A little summary frame. And then now we're logging metrics, which are different than parameters, right? Metrics might be your R hats, your number of divergences. It could also be coefficients, right? So means of coefficients might be a way that we might start combating data drift by logging these coefficient values. Again, you can log whatever you want as long as it is a float, int, or whatever. Well, you can really log everything, but if you want to log a metric, right, it's got to fall in one of those categories. And this is where you really start combating that data drift, right? Is by understanding how are those coefficients changing between runs? What's my divergence between different posterior distributions, stuff like that. This is where the magic starts to happen. I think I saw a question come through, Brian. I don't know if we want to.
Sorry about that.
No, you're good.
Um, all right, so let's answer live. I think that's what it is. All right, how often do you rerun models to be able to track all these changes?
Great question. And I'm going to give a bad answer, and that's it depends. I think it really is context dependent. Again, when we get into those examples at the end, I will give a little bit more concrete numbers. Some models, right, you want to retrain almost every day, sometimes every hour, right? If I have a model that's forecasting the number of SKUs that are going to be sold tomorrow, that model better be, that re-inference better be done at least weekly, right? If I'm not doing it at that level or more for those kind of models, then I might be losing out on the data drift and stuff like that. Or maybe, it's a large company. We might have had a lot of data drift in the context of covariance shift or all this other thing. So it is context dependent. But if you want, we can get into that when we go into the examples.
Very cool. And yes, we are recording this live. I think there was another question about that. I'm also going to close out this question because we answered it already.
Awesome.
But very good. All right. So there's no more so far. All right. Let's keep going there,
Cool.
sir.
Awesome. So this is step one. Obviously, there's a lot more, but this is how you start combating that data drift. Um, you can also log whatever you want. This next part of logging is what's called artifacts. So if you want to log a CSV, so maybe you're trying to get your RVIS summary into a format that you want tracked for later on, you can log it as an artifact. You can also do PNGs or your netcdfs from your PyMC model, or if you are doing scan, then maybe your draws array, stuff like that. You can do whatever you want as an artifact, and MLflow will happily handle it for you. All right. Whether you're using Databricks or Snowflake or whatever cloud provider, it doesn't really matter. You can of course use MLflow locally. It'll work just fine. But we use Databricks, so I do want to show what that would look like from a Databricks perspective, right? So let's say I've run a bunch of models, I've done a bunch of runs. This is an example of what an MLflow dashboard might look like for a model run or a bunch of model runs. Here, this is just a demo, so there's really no real data here. But if I'm running like a simple logistic regression, right, I might do a bunch of different runs. I might change a bunch of different things. This is what that output would look like. I'm sure some of you have probably seen this kind of naming convention before. That's MLflow for you. It chooses an adjective, an animal, a number, and then bam, that's the run number. So it's kind of silly, but programmers are silly. We can also use this dashboard to just click around and understand how are our models behaving across runs, whether this is in production, right? So I'm trying to monitor drift, and every day I wake up with my coffee and I go to see how Mr. Logistic Regression did overnight, right? Or if I'm doing experiments throughout the day, how it's performing. So I can look at this little trends tab and I can see how these parameters are changing throughout my experiments, right? So maybe I'm seeing if beta mean is what it should be doing, or If my intercept is 0, which it should be, right, and all this other stuff, right? What's my R hats? Is it below 1 or at least at 1, right? What's my effective sample size? Stuff like that. This is the kind of thing that the MLFlow dashboard just services to you right away, so you can dig in and see if things are changing, right? And these are all Bayesian models, right? Where we haven't really left that regime. We're just using MLflow to our advantage. I talked about all those things you can log, right? And all I did here is just click into one of the models um, and kind of pop around with the quote unquote artifacts that we've been collecting, right? So one of those artifacts was the posterior summary, right, that we got from RViz. And literally all I did was click it, and I get a nice little table that shows me how that model performed at a very much more granular level, right? So I'm not writing any code. It's just a nice UI that's clean and you can just easily navigate, right? So it makes tracking data drift and everything else, in my opinion, a breeze. That was MLflow in a nutshell. We are going to come back to Mr. Flow, but before we do that, I want to touch on really the third principle here, and that's the object-oriented state of mind. So this is a little bit of a soapbox for me. This is what I've found to work over the past, 4 or 5 years, well, longer than that. And I'm giving this to you. You don't have to take it. You can, leave it be. Um, when I'm fitting models, I find it's very productive to think of your models as objects. And what I mean by that, you might be, thinking about, the class structure and stuff like that in Python. But if you're an R guy, you can do your S3, S4, R6, S7, whatever the number is today of our object-oriented one in R, right? Just thinking about it from an OOP perspective, right? And these objects, who are, again, me, I'm examples. So we're going to see an example in a second. But as we're thinking about it, these objects should be encompassing of all the actions you might want to perform on your model, right? They should have a data method, probably. They should be able to do something with fitting. They should be able to do something with predicting, whatever, right? But it lives underneath this model object. And because they are kind of encapsulated in this very well thought out system that you've produced, you can stack them together into other classes, right? Into other objects. And this is very easy to do with like ensembling modeling, right? So let's say that after you fit your Pareto smooth and Porter sampling, right? You of course get those weights from each model if you're doing comparisons, and then you can do ensemble models to combine all the best parts of all the models that you've been fitting so far. So again, it just lends itself to this really clean workflow. Of course, it's extra work up front, but what have I been saying? Your model will thank you later, and this is very much the case as I found with this one.
Very cool.
Yeah. I get excited about this stuff. If you can't tell already. All right. So let's do an example, right? So again, this is Python, right? You can do it in R. Nothing's stopping you. But a lot of the things that I've been doing recently have been more Python focused, so that's kind of where I'm pulling my examples from. So it's really not scary. All I'm doing is I'm saying, all right, let's start a Bayes object. Let's start a Bayes model object. It's going to have these attributes, which makes sense, right? A lot of models better have data, and they better have a model, and they better have some other metadata that kind of dictates how they interact with either themselves or other models. Usually you're going to have static methods that don't really do anything outside of the class object, but they're more helper guys in the behind the scenes, right? They're like little elves that kind of keep everything organized for your little model object, right? So this might be like a data builder method where you're going to give it some raw data and it's going to fix it exactly how it needs it, and then bam, it's going to put it as an attribute. So there's a lot of these ancillary functions that will live in your Bayesian model object, especially for Bayesian model objects, because us, we're kind of like bespoke by nature, right? We like to do things our own way. This is the perfect way of just continuing that into your production workflows by building these classes. Got to have a fit data method, right? You got to accept data in some way. And the first thing that we're doing is we're setting our attributes. And look at that, we're already using one of our little elf functions to start helping us out and build things out, which is our ancillary data builder method. So that's how we're going to set our data for the Bayesian model object to further learn. The all important fit method. So if you're not defining a fit method, I don't know what you're doing, but probably not modeling. So again, here we got our PyMC model, and we're gonna define it. We're gonna do our sampling to get a trace and a model object, and we're all hunky dory. This one, I bring it up because it is so important, and it's something that I think unlocks a lot of strategic decisions for Bayesian modelers, and that's a set data object. So you're always going to be shifting, whether you're working with standard PyMC, you're going to be shifting the data you want to use for either inference or for predictions, right? And to have a method that does that for you is in my opinion, a must, right? So what are we doing here? I'm saying, all right, let's accept some data and let's tell the model this is now the data that you're going to use for the next thing you do. Whatever you do next, you're going to use this data. And look at all the elves that are working behind the scenes for our predict method. So we're going to build our data. We're going to set the data, right? That we're recalling that method we just used. And now I get to use my sample posterior predictive and I return a pred object. An end user would never see all this gobbledygook behind the scenes, right? They could just work with this nice little API that you've built for them, and that's really going to lend itself to the next part of this in a second. But before I get there, your model's an object. Treat it like an object. You can give it properties. You can give it um, um, all these things, right, that an analyst might want to not really call, but just understand, right? Give your user a way for them to interact with it, how they would like a sklearn model, like a pandas data frame, stuff like that. You're basically building an API. And then the last one here that I think is almost super beneficial, especially if you're handing this off to your buddy that sits next to you, is a quick setup class method, right? So something that substantiates the class, creates a fit method, fits it, and then returns the model back to you. So again, it's just keeping things clean and tidy. And I really include this one because I think it's a must for all models that make its way into production. Is a way to quickly fit it, right? Put all those methods together and bundle out nicely. All right, I said we're going back to MLFlow, and we are. It's going to get a little scary, but I believe in all of you. Look, just one line of code. It's not that scary. We're back to MLFlow, and MLFlow is a huge ecosystem, right? Where you can interact with sklearn, where you can interact with Onyx, and all these other different, bigger modeling frameworks. But stand in PyMC, they're a little bespoke, so we're going to do things the bespoke way. All you have to do to activate the bespoke mode of MLFlow is to start working with this API that's called mlflow.python model. Again, there's an analogous one in R. I'm just showing the Python version. We only have to define one more class. We're so close. This class is going to help us bring that model that we just defined here into the MLFlow ecosystem. And it's going to be super quick, super painless, like a Band-Aid. The first thing that we have to do is take some sort of MLFlow context and expose it to the model that we've just created. So it looks scary, but it's not. This function is going to accept an MLFlow context. So we're familiar with context, right? We just saw what MLFlow looks like in dashboards, right? We saw that one model has artifacts, it has this, it has that. And that's all that this context is accepting. It's going to basically be a bunch of collections of the artifacts you've already fit, right? So we're going to open our model specification, and we're going to open our trace because we're using PyMC, so we always need an iData object. Again, if you're Stan, this probably looks like a draws array or something like that. And then we substantiate our base model, and then usually we have, again, some sort of elf ancillary method that's going to set the attribute for us. And then all you got to do, define a predict method in your base model MLFlow, and then you're ready to go because you've done all the work up front. And really, all you're doing is telling MLFlow how it should be using your model. That's all this is. It's just some instructions for MLFlow to use further. I need water. Okay. the last step, and I promise, I think this is maybe the last bit of code that we're going to look at, is we have to log this, right? So we logged parameters, we logged artifacts. Indiana Jones is ready. The last step is logging a model, right? So we have to tell it where to put this model. We have to tell MLFlow the class that we just made, right? MLFlow has to know how to interact with it, and we have to tell it the artifacts it's going to need in the future, right? And if you want to, you can tell it the libraries and stuff like that, but it's not really a requirement. And that's it. That you've done it. Your model is basically in production. If you're using Databricks, if you're using Snowflake, if you're using whatever, all of them have APIs to pick up this MLflow object and just start using it. It can be used in a bunch of different ways, and a lot of them we use today, right? Where you might want to serve this and have non-statisticians hit it in SQL. How are they hitting it in SQL? MLflow is handling all that for you. You've told it already what to accept, right? You've told it that this model input's coming in. It knows how to, it knows what it's got to output. So a non-statistician that doesn't even know what a PyMC is or a stan is can hit it using SQL by feeding it tables. It's pretty powerful stuff. Your buddy, the data scientist that sits across from you, can use it and not even have to worry about handling different libraries and stuff like that. Or if you're really slick, feed it into a Power BI report, right? It lives in your Databricks ecosystem, right? It can be accepted by anything that can connect to your Snowflake or Databricks pipeline. So this, I know we're not going all the way to the end, right? You're not seeing me, writing SQL code, which you probably don't want to do. But I promise you, the hard part is over. That being said, if you want to ask whatever grande language model you want to use, and it'll probably get you to the next step of this, right? You've done the hard part. The easy part is just piping it into whatever your company is using. All right, the last basic one, and there's no code for this one, and it's a bit of a tautology here, but I preach this all the time, and that is that a usable model is the only useful model, right? We've been talking about all this really coupe de gourmet stuff where we're using MLflow, we're using Databricks, we're doing this, we're doing that. But if no one can touch it, if no one can use it, then it's really, who is it for? It's for no one. So that's why I really do want to talk about what production means on the lowest level to the highest level. So now the fun part, we get to talk about some examples, and through these examples, we're going to kind of talk about the different, let's say, strategies I've had to employ to get through the different infrastructures that have been with us, right? Because I'm sure some of you can empathize. We're an older company, right? We have that infrastructure that's brand spanking new. It's shiny and stuff like that, but we still have those old databases from the 90s that a lot of people still use. So you have to be scrappy, right? You have to be able to get it out now if it needs to be out now. Use older infrastructure. You can't always use MLflow, unfortunately, as much as we would like to. So get it out now. The kind of project I'm gonna say we're using for this is a risk assessment project. So the objective for this one is to produce a model for our asset protection folks. So that's our team that monitors the safety of the stores, right? That determines a risk associated with each store, right? And this is a counterfactual graph from one of them. I'll dig into that. Obviously, I can't show what the numbers mean, but it's a nice visual. Lets you understand that we're concerned with uncertainty. This group probably does care about what the model is. This is a component ordinal regression model that considers the external data that we have from vendors as well as internal data that we collect. And we use that to classify a store's risk, right? I say component because we're modeling not only the risk to theft, right? That's important, but at our company, the most important thing is our people, right? So we also want to consider the risk to our people. So the totality of risk is really a combination of two different, or really three different models, but neither here nor there. What are we using these things for? So it's very important that we're allocating the asset protection labor in our stores correctly. So these models help with that. The counterfactual based forecast. based on how we think things might change in the market. Is something going to get more or less quote unquote dangerous, right? And that's what this graph is actually showing is we changed something, right? We flipped on a switch. Maybe there's a new police station getting built or something like that. And this is kind of how things have changed. Again, you don't need to understand the numbers, just understand that, you can kind of see the sliding gradient here. And we're very concerned with uncertainty in our numbers, right? So this one, again, we're just getting it out, right? And sometimes the scary solution is the best solution. So for this one, we actually use Stan to sample the model I just talked about, and the samples are stored in an Excel spreadsheet. And the main version of it lives in a SharePoint and is available for analysts to download and save. Obviously, they don't see and interact with the samples. We built a little bit of a UI in the Excel spreadsheet for them, but um, you know, nothing's stopping you from downloading the stand samples and just, doing all of your methods within an Excel spreadsheet. That is totally viable. And if people can use it and it's giving people value, that's in production, right? There's not always have to be something fancy. We can still use some top line production basics when we're doing these things, right? So, for instance, you can use local MLFlow to track model versions to do drift tracking of different things, right? You're not fully incapacitated. You can still do these production basics to set yourself up for the future, even if you're not deploying it on these large servers and stuff like that. And then, of course, iteration tuning, especially for a model as that can be as nasty as this one. This is what the output looks like. So obviously I'm not going to show stores or store names, but this is what an asset protection analyst might consume on the front end, which is, understanding what is the risk associated with stores. And because we're using Bayes and because we get uncertainty for free, you can determine the number of simulation samples that fall into the different buckets, and you get this uncertainty for free. And you unlock this is huge. You unlock a new layer of nomenclature for the asset protection team. Instead of saying a store is low risk, a store is high risk, they can now say, well, it's low leaning medium, or it's moderate leaning low. This is because you're using these Bayesian models, you get that for free, as well as, of course, being able to fit the model you want. I'd be remiss if I didn't show you what the Excel spreadsheet looked like. Obviously, this isn't what the analysts are doing, but this is it, right? This is one of the hidden sheets, and it's just a whole bunch of draws erased from Stan. I'm pretty sure this was a divergent transition. I'm just kidding. I have no idea. But these are just huge draws arrays that are living in one of the Excel spreadsheets. So that's the quote unquote get it out now version of a model for Bayesian production. I think I saw another question pop up, Brian. I don't know if you want me to
Yeah,
speak
yeah.
further, but
So we'll answer this live. So can you give a couple reasons Bayesian modeling might be preferred over machine learning algorithms like XGBoost? I could say, you want to go take this one, Ian, or yeah, go.
I'm sorry. I can do that. Or do you want that, Brian?
I mean, one of the things I would say is really just like dealing with uncertainty, which you don't get with tools like XGBoost or even traditional models like that, or frameworks like scikit-learn. A lot of traditional models just don't deal with that, and it's actually like it gives you that sort of. It's a general thing I would say is it would give you sort of an additional level of like responsibility even at your company, right?
Yep.
Yeah, and that's just like me talking like in a general way about it. Ian, if you want to chime in and say like if you have anything that you could say that might add to that, I think one of the things I would say is, if you're looking at things like risk, like loss prevention, like damage, or even just like basic things where there's a huge amount of like not just I guess what I would say is if there's a huge amount of like sort of loss around or even just responsibility around just loss mitigation, that's another thing where you want to have something like this.
Yeah.
That's go ahead.
No, I think the great response. I think the only thing I'll add to that is, one, you're going to see on the next slide actually, but I'm not adverse to using XGBoost where it makes sense, right? I think XGBoost is a great tool. if you're a guy that loves trees, right, you love your nature, go ahead, use XGBoost. Or if you want to stay in the Bayes world, you can use BART, right? BART is a
Yeah, yeah.
fully Bayesian,
PyMC, Bart. Yeah.
yeah, BioC
Yeah.
BART is a fully Bayesian tree method, right? I think, and I've kind of, again, I've said it before, but with Bayes, you get to do exactly what you want, right? Let's say I'm fitting an XGBoost model, right, for time series data, which you can do, right? Nothing's stopping you with time series data, right? But I want a particular function to live in December, right? I want this maybe decaying exponential or increasing exponential for Christmas, right? A build up to Christmas. But I only want it to live in this 1 month, right? That's a very hard thing to do in XGBoost, right? That's not feature engineering. That's not hyperparameter tuning, that's model engineering, right? I've left the realm of like normal stuff and now I'm building these super bespoke things that fit specifically to your business. And that's really where I think, use XGBoost when you want, but as soon as you need to do a little bit more business specific things, you're either coding your own maximum likelihood estimator algorithms or you're turning the Bayesian crank and having a field day.
Yeah, I think that's also what motivated tools like Profit, right? Like when people were trying to figure out how to do proper forecasts and they couldn't really do them in like a where that like it really showed how like forecasting was really done. Like they had ARIMA models, but it's not exactly giving them exactly what they want. You looked at tools like Stan, which allowed you to actually make custom models, really, and not even like something that's a crazy Bayesian model, but just something that's like these additional features you don't see in packages anywhere. And that's like another thing that you could look at Bayesian frameworks like Stan or PyMC about. It's like you can do more custom things that are like more tailored to your business.
Yeah. Yeah. Great question, great
All
response.
right. And then we have another one. It says,
Oh, okay. Yeah.
can you share how Bayesian can be useful in fintech? I'm working in a fintech company. Which analysts of like do bank data use ETL database processes? So I think how can Bayesian models be useful in fintech, like financial engineering,
So,
financial? Yeah, go ahead.
mhm, yep. No, I think so. One, I don't work in fintech. I'm very lucky to um, work in retail because it's and I'll be honest, in my perspective, it lends itself more to the Bayesian lens. But that's not to say that fintech doesn't. I think there's probably a lot of things. I don't know how long you've worked there, and I don't know um, how long that team has been established, but as soon as a little bit of business knowledge starts to come out and people want to tinker and play but don't exactly know what a distribution is, right, that's where you become the translator to bring it to a context where it becomes you know uh, uh, hyper specific and hyper bespoke, right? The first thing that jumps out to me with fintech, right, is clustering algorithms, right? I think I see it all the time where um, I have colleagues that are writing blog posts on um, doing either if you're doing portfolio assessments, right, there's risk in that. And probabilistic clustering algorithms are huge for that, right? Understanding whether this is high risk or low risk or right in between, right? Your classic ML algorithms won't really be able to handle that very well, especially if you want to understand is it in between high and low risk, because it's always going to give you a point estimate. So that would be my top of the mind take. But there's room for it everywhere.
Yeah, I think it's also context based too. Like, I'm not exactly sure what part of fintech you might be in. Like, it could be like a business where maybe you're a private equity firm, or like if you're somebody who deals in like certain types of trading, stocks or commodities. You all like are looking at different aspects of your business that like you care about, and maybe there are use cases where actually they fit better than others. Like I think it just depends on like what you're trying to answer, and then also like like a lot of data science is kind of like gearing towards certain tools for specific problems. I would say like Bayesian models are kind of like that too. Like if you can use a traditional linear regression model and you get a meaningful result from it, great. And that helps your business, no problem. Maybe you don't need to go down this road. It takes a lot more work to go down this route, like I think, but it's worth it. So,
Yeah,
all right, yeah,
great response.
very cool. All right, want to keep on keeping on there,
Yeah, let's keep
PMC?
on. We got
Yeah, yeah.
we got a couple more slides left.
All right,
We're
cool.
almost there, guys. We're almost there. All right, so this is an example of a model that kind of has to live on older infrastructure. So the objective here is, the marketing or whoever comes to us and says we want to understand our customers that are likely to be cross shopping with a competitor, right? So I put up this little map here that shows Wegmans in blue and Trader Joe's in red. And the marketing folks are, the merchants want to understand who's likely to be cross shopping, right? Again, this group cares about models, so I'm going to show the model. So here we're using, your kind of vanilla GLM for logistic regression, but because again the business is specific as to how they want to turn on and off covariate behaviors, we use cut point detection. It's quite quote unquote beefy, so around 50,000 uh, um, uh, people, 50,000 customers, and then 3,000 covariates. So what's really cool is we're using XGBoost for feature selection as stage one, and then we actually use a horseshoe prior to get a really tight regularization on those coefficients that we end up using. So we don't obviously use all for 3,000, but after doing a lot of selection, we get down to a set we feel really good about. We use this for sending targeted communications as well as measuring successive campaigns. This can be for like a whole bunch of different models. Their whole purpose, right, is to understand and segment customers. This is huge too, right? If I'm understanding that my campaign to go after these customers is resonating with those that we said are cross shopping. So this one is deployed via an older SQL database. So again, no one's stopping you from downloading your draws as tables and uploading them as SQL tables, and that's exactly what we've done, right? Don't listen to the man. You can 100% code up matrix multiplication in SQL. The world is your oyster, and that's kind of what we've done here, where we've coded up these large stan arrays after sampling, put them into SQL, done our own matrix multiplication functions and stuff like that in SQL, and then you are able to implement whatever push forward distribution you want to get that either map estimate or in most of our cases it's some sort of quantification of the area around the map estimate. And then, we're always using our basics. So this one is huge, right? Got to use the QR decomposition. This is a must for these kind of models, especially when you have, you can think about how much does it correlate between buying yogurt and, buying cheese. It's pretty high. It's a pretty high degree of correlation. So if you're not using your QR decomposition, your model's going to take a long time to run. So you're also using your reduced sum and stuff like that. And then, of course, you can use local MLFlow for model tracking and data drift and all that. All right, and this is the Coupe de Gourmet. This is the most recent model we put out, and I'm like, this has got it all. This is the one I'm going to use for this talk. And this is a new model we put out to measure the success of direct mail campaigns. So direct mail, this is, for some of you in our market areas, you actually received this recently, right? And our goal is to determine the incremental sales that are gained by sending out these pieces of direct mail. And we're very fortunate that we have buy-in from the business to actually have a randomized control trial where we hold out a portion of the population to receive the mailer, and that's how we're able to get really good results. This is actually a self-serve model, so the analysts are allowed to interact with it themselves. I'll go to that in a little bit of a second. But it's a two-stage model. So first we model the intent to purchase, and then we model, given a purchase, what's their basket size going to look like. So this two-stage model is, one, very robust. Two, you can already see we're getting kind of bespoke, right, by building two stages of the customer behavior, and then we can use this to determine their incremental sales. And like I said, this has got it all, man. This has got MLflow tracking, all that. So this is deployed actually via Databricks apps, and I'll kind of go into what that looks like and what it actually looks like literally looks like in a second. So Databricks apps, as I said, this is a self-serve model. So we host it using MLFlow, but an analyst that doesn't have a lot of experience with stats can actually interact with it without knowing it's happening in the background. Databricks is smart enough because, again, you've seen how we did all that code. Databricks picks up that model shell and then fits it based on whatever the analyst gives it. And grab your Nissans because this is a straight Pathfinder implementation. So Stan is using Pathfinder in the background to get a very quick result, right? At the core of it, these models are pretty basic, right? They are really just linear models and GLMs. So that's Pathfinder gobbles that right up and fits it really fast. But because we have full control over everything, after that model runs, we have a separate production job that actually does the full MCMC pipeline, fits it as you would, and every other day, and you have a job that goes and checks to make sure that your Pathfinder inference is the same as your MCMC inference. If those diverge, then you get a result and say, or get a flag and say, please check this. But for the most part, again, because these are so vanilla models, that rarely happens. But again, we're talking about a lot of pieces of mail that are going out and big investments. So you better believe that I'm trying to make sure that we're as compliant as possible. So that's why we do this MCMC job in the background, and of course make sure it converges. MLFlow is logging both models. Of course, the analyst doesn't really interact with the um, uh, model after it's fit, right? They're more concerned about the inference that comes out immediately from it. But for us, right, we might want to debug later, and MLflow is a great framework to be able to save all those things, so we can very easily be like, oh, looks like it failed here, and this is how we fix it. Um, a nod to my R users. This was actually built in Shiny, so it's a fully functional Databricks Shiny app that uses Stan in the back end. So it's again, it doesn't get much better than this, guys, for my Stan users out there. All right. And this is what the actual front end would look like. So an analyst would pop in their CSV. They can change a couple of different things. So this really all this does is change the formula on the back end that fits the model. And then they get, of course, I'm blurring it out because I don't want Whole Foods stealing our data. um, but it gives the analyst, the incremental numbers and stuff like that by zone, by some other customer metric, and they can export that, and they would never have to worry about what a likelihood function is or something like that. So again, and all that other stuff I talked about happens in the background that never gets seen by the analysts. So um, that's it. You guys did great.
Very cool. Very
That's
cool.
that's all I have. Like I said, these are the references if you want to dive in more, and I'll stick around and answer questions because, as you can tell, I love doing this.
No, that's awesome, and thank you for doing this, man. So we got a couple questions by some anonymous people. Very cool. You guys can keep your questions anonymous, no problem. So let's answer live. How do you quantify model performance from a probabilistic standpoint when using Bayes? Okay. Do you want to go on that? Yeah.
Yep. So, um, what do you get out of a Bayes model, right? You get posteriors, right? So again, the world is your oyster, and sometimes that flexibility is scary, but once you learn to harness it, it becomes really powerful. Um, I know that was a little vague, but let's get specific, right? Let's say you want to calculate your RMSE for a model, right? Or your accuracy or something like that, right? Because you have posterior distributions for all your customers, right? You can actually get uncertainty quantification for your model performance metrics, right? I can say that on average, my accuracy is 80%, but the distribution is maybe it's not even unimodal. Maybe it's a bimodal thing where I have a step here that's at 80% and a step here that's at 85%, right? Something you'd never get in any other framework. And it's a little bit counterintuitive. What do you mean I have a distribution over my target metrics? But it's true. You can do that because you have that ability to push forward things, right? So if you want to get point estimates, go ahead and get the average value for the posterior distribution for each of your customers, and then use that to calculate your RMSE or anything like that. Like nothing stopping you there. That's how you would do it in your classic, frequentist framework. Or go ahead and go full Bayes and get a distribution over your uncertainty, which is pretty big too.
Very cool. All right, and we got another one here. Do you use any LLMs to produce your solutions? Also, are the models exposed to AI agents in business workflows? How are they typically consumed by the business?
So kind of a two-parter. Do we use LLMs for the? I guess the question was, are LLMs used for the models for the model building?
Yeah, and then also are there models exposed to AI agents and like the business workflows? So like are they aware, for example, are other AI agents aware of like the
I
models
see.
you've
Okay,
produced? Yeah.
so great question. The first part of that, I'm going to be honest, I don't really feel like AI agents are at the point where they're able to write really good stand code.
Yeah.
I've learned a lot from what Bob Carpenter has said on, kind of writing that boilerplate code, using it as an assistant, which is what it should be, right? But I don't think it should have the full reins. But I do use it to write a lot of boilerplate code, right? Like if I'm like, please, plot this for me. It's really good at that, especially when you can hit run. And if it works, it works. If it doesn't, it doesn't. A little bit harder in the modeling framework, right? Because your models will lie to you all the time. And unless you really know what you're doing, I'm, a little bit hesitant to let it take the reins fully. But boilerplate code for sure.
Yeah, I
Um,
tend I tend to feed it documentation first before I do anything.
yes. Yeah.
Yeah.
Um, the next part of that is really insightful, and that's, do AI agents have the ability to consume them? One of the great things about MLFlow is that if you're using it with Databricks or Snowflake, you have the ability to log it in those systems, right? And if you're, it depends on the size of your organization, right? But for us, because the organization is at a point where we've kind of invested in that infrastructure, if you're using Copilot or anything like that, they actually not just have access to whatever model you built, right? But they have access to data that lives in those hubs, right? In those
Yeah.
places, so they can pull it in. And MLflow makes it so that your models don't look any different than saying select star from a SQL table, right? So yes, in theory, the AI agents could 100% use those models, but we don't really do that yet. That's not really part of our workflow.
Yeah, and they're I think they're wondering how they're typically consumed by the business if they were. I think that's probably to each their own, right? Like on like what their business use case is. Maybe it's more beneficial for an AI agent to have like access to your models in case they want to actually know something in particular, like a business report or something, or like I think it's just it all depends on how people are consuming analytics at your company too. Like most of the people I see who go through and use an AI agent to sort of get insights about business or analytics, they tend to are not going that deep, like in terms of like what you're trying to understand. Like they in terms of like analytics or even engineering. Like so like yeah, they're not requesting like Bayesian like answers, right, from
Yeah,
stuff. Right.
yeah,
It's more just like how likely is this to happen? And maybe they don't see like anything behind the curtain or like what goes on there. It's just like that. All right, so that's okay, that's done. And then here, Tyler Kraus, I think. Please forgive me for any mispronunciation. How do you translate a complex posterior distribution into a user-friendly confidence score or risk level that a non-expert like yourself, don't worry about that. Everybody's learning. Can actually act on without being an expert or on stats. So like how can you translate complex posterior distributions into user-friendly confidence score or risk level that like people can interpret that are maybe business people, right? Or non-experts.
so Tyler,
Yeah.
hello. If I know that Tyler, I think it's the one I know. Um, uh, so you actually kind of already saw it, right? When we were looking at that risk assessment model, and I stopped sharing so I could see the Q&A, and I shouldn't have done that because as soon as I did that, it made sense to show. But if you remember, right, I had that one slide that showed the percent of stores that are moderate, elevated, stuff like that. If you remember that, that is literally me taking a posterior distribution and putting it into those buckets, right? So you can think of like if it's like a normal distribution, right? Put two bars somewhere on there, right? And the mass of that distribution that falls below this bar and then above this bar and then so on and so forth, right? That's how you would take that complex posterior distribution and then push it to something that a business understands, like percent of the stores risk that's moderate or elevated or stuff like that. That'd be a nice way of translating the two.
All right. Very cool. All right. And then Mariana Carmona, again, forgive me for any mispronunciation. Great talk. Thank you so much. Okay. Working on some Bayesian spatial models that are notoriously slow and usually. Oh, okay. So compliment, I think, here for you. So Have you found a way of implementing spatial models in production apart from using approximation methods like NNGP? Okay.
So,
So
yeah, go ahead, Brian.
no, I think there are other frameworks that are like useful for spatial models, like the spatial disease model, like INLA is still pretty popular, very popular for that still. Like even I think there's even some frameworks like in PyMC that are adjacent that are coming up, but they're not still at that level yet. But go ahead, Ian.
No, I think the only thing I'll add to that is if so, I don't know if you follow Mitzi Morris at all.
Oh
She
yeah,
does.
I know. I don't know if it's yeah.
Yeah, she loves, from what I can tell, she loves spatial models, and she has a lot of great writing on how best to build them and stuff like that. But Brian's answer on Inla is what I've found to be useful in the past.
Yeah, there's that. And oh, Mitzi does amazing work, by the way.
Yeah. Yep.
Yeah, and then she like inline is useful, but also like there are techniques coming up in Stan, like not even coming up, they're integrated with like Command Stan 2.37. I think like Laplace also is part of that. Like also people are, I've seen more integration of like geospatial models even in like the franchise business model of like doing things like I was at a company where we were contemplating using InLab for looking at like just geospatial like effects of like risk like on like studios we had that are open, right? Like stuff like that is pretty popular. um all right, very cool. And then also here for an anonymous person, how do you explain to your stakeholders that your models are probabilistic? In my experience, they usually want to know if it works or not.
I think, it all depends on how you're talking, right? As a data scientist, half of your job is talking, right? So it's if you believe in it, you have to make them believe in it, right? So if you go out and you say that, yep, it's gonna say 0 or 1, kind of, right? It says maybe the customer's doing this, maybe they're not. I think that, right off the bat, the person might be like, whoa, what do you mean it doesn't know? But if you were to say, well, in the frequentist context, it's just that, except it lies to you and gives you a point estimate that we all ignore that confidence interval on because it's not important, right? Versus the Bayesian method, which makes you explicitly confront that assumption that's happening at the output of your model, right? And I think that's something that's hard to bridge that gap with the business. But in my experience, when you're talking to the business, and if you have confidence in the model, most of the time, unless it's, I don't know, maybe it's like pharmaceutical industries where they're really specific on those outputs. But even then, right, I think the FDA just came out with something on actually how to use Bayesian models the correct way. So there's no excuse, is what I'm saying. If you can use Bayes and talk to stakeholders in a meaningful way. And you might not even have to say base, right? If you can give them point estimates and you can be like, the model's doing this well, we're going to run it. And they go, all right, go get them. So I think it all depends on how you broach that topic.
Yeah, I agree with that. I think one of the things is also like introducing nuance into like a conversation is probably another thing when you talk to business lead. A lot of people, a lot of business leaders probably are not going to understand this like a little bit. So you do have to go into this like frequentist versus Bayesian thing. I think that's kind of like what you're touching on there again. So the part of that is like telling them what are the limitations behind like the current models you do. What does this give you? There's that piece, but trying not to be like stuck in like technical jargon. That's another thing.
Yep,
Yeah.
100%.
All right, this is awesome. We got another one here. How can we find other people or examples of Bayesian models in production? Is there a club for this? Um, no, I don't know if there's a club, but there's definitely like I think when I was like trying to think about the talk, one we're working on a proposal, and heads up, we're working on a proposal for Onyx to kind of like get work with more Bayesian frameworks. So like we were kind of like people are thinking about this stuff, and also I don't think there's a club, but there's like I mean club like any, but like there's definitely a good number of people who do want to talk about like what does production mean or like MLOps mean for Bayesian models. I know at work they're talking about that, and part of it is also you know a lot of MLOps now is like getting very mature. And I think that's like where things are happening where like, maybe 6 years ago you could make a case saying like, why are we engaging in MLOps for? Even like we do what we do like every day. It doesn't have to be like this huge production of things. But now like there's tools everywhere, right? So like if you're getting into like stuff like this, like production models, like not only is it like the use of tools like what Ian is talking about, like MLOps, like tools like MLFlow and Databricks, but it's the other stuff he mentioned, right? Like it's the stuff like the techniques he's using just to make things run faster, right? And like the checks he's doing, like that's also like a production level set of like techniques you can use, right? If you want to add to that, like
Just
yeah.
one quick thing I'll add to that, and what I hope that I've done throughout this presentation is demystify a little bit, right? And my big thing to take away is that adding the word to Bayesian models shouldn't be scary. What we you can productionalize a GLM model today, right? By putting it in an Excel document and sharing it with your two best friends, right? That's production. A usable model is a useful model, right? So I think it doesn't have to go, find this crazy example where someone's using MLFlow, right? Just start today by saying, how can I share this with people, right?
Mhm.
And then, of course, follow the best practices and stuff like that when you're there, but just, keep going, right? Um, any Bayesian model can be a production model.
Very cool. All right, and then Scott Siriday. Again, forgive me for any mispronunciation of your name. Sorry about that. Have you seen many applications for Bayesian causal networks? Seems very interesting but challenging.
So I'll add one. Brian, you probably have more to add, but I'll got some in my eye. I'll add one quick thing. So I showed the risk model, right? And that was it wasn't at all a BCN. It wasn't a Bayesian causal network. Um, but we've gone beyond that with the asset protection team and have built these Bayesian causal networks, similar to how you might, like if you've read Mikkel Reith's textbook, right, or I think like Judea Pearl's book,
Yeah,
right,
yeah,
like those
yeah.
kind of like bring it up, right, in like the context that it should be interpreted in. We've built things like that. And really, the hardest part, I think, is thinking, right? Because for most of them, you're just stringing together disparate LM functions, right? And yeah, it can be hard to reason with, and it can be very hard to code, right? Especially when you want to do inference on them. But from a inference standpoint, and once you have your model defined, it shouldn't be that challenging. And of course, you can put them in production, right? It's really just the thinking portion that I think a lot of people have challenges with.
Actually, a good framework that I think I was trying to find out more about it last year or so, but I think they may have stopped working on this was causal nexts. And that was something that, like, if you looked at McKinsey, like they had this Quantum Black Labs group kind of work on a lot of different tools. I use one of them called Kedro, which is an MLOps tool. But like they also had like a Bayesian causal networks framework that like was getting it still is like a very popular package. Like you'll see them got like a couple thousand ratings on their like GitHub. They just maybe like don't contribute very regularly. But that's a really cool framework to check out. Causal Next. If you want to see like McKinsey, I think was using it as like part of like their consulting practices for a little bit. Don't know. I'm hopefully if anybody from McKinsey's here, just you can correct me. I don't know if like something new is coming out, but that was a really cool thing. We should keep that going.
I've also seen a lot of people do stuff like that, especially in the psychology phase with oh my God, it's the SEM package that is in Bayes now. I think it's built on BRMS. I can't remember the name of it to save my life, but um, that one's used quite a lot for psychology.
Uh,
Do you know if you know Brian what that's called? But I forget.
no, no. It's weird. I don't see a lot of like. There was this like like other Bayesian networks like tool that I think even like was used by the Department of Defense at one point. It's like Bayesian Labs or something
Mm-hmm.
like really like it's like click and point software. But like people
Oh, okay.
have used Bayesian causal networks like for other things and like really situational like modeling. It's kind of a weird it's I shouldn't say weird. It's like it's not a niche thing, but it's like a newer thing that I don't think has like a very good established like, you know, say frameworks for anything yet. So like that's where I haven't seen anything like that for like Stan, like nothing like that yet. But I could be wrong. Please correct me if you want. Okay, and then we got another one here. How closely do you work with analysts or subject matter experts to craft your priors?
Great question. My answer is all the time, but they do not know it. And what I mean by that, right, is of course, I'm trying to regularize my model to the best of my ability, right? So I'm always going to ask probing questions, but it's very rarely, when I'm talking to a merchant, I'm like, do you think that I should use a mu here of like 1 million, or is that more like 2 million, something like that, right? I would never ask a question like that. I might ask, well, what do you think this product's going to do next week in sales, right? And that's prior elicitation, but they don't know it. All right. I'm always trying to gather information from people more knowledgeable than me. One of the tools that's really helpful with prior elicitation in PyMC, again, not good with the names, but there's a new framework. I think Alex Andorra did a lot with it, and that is, you can kind of set parameters on what you want the the posterior or the prior distribution to look like, and then it'll find the parameters that govern that for you. So that's really helpful if you have very strict priors and you want to like immediately say, yep, this product will never do less than 5,000 units this week, right? So that's really helpful for setting priors like that. So always talking to subject matter experts. They just don't know that I'm using them for prior elicitation.
Very cool. All right. Um, Very cool. I was gonna say we have like maybe 2 minutes left. Does anybody have any more questions? Oh, all right. I'll give it a minute. I got all right. I think that should wrap it up then. Oh, okay. How can we stay in touch? Yeah. So one, you could always like I'll post a LinkedIn like my page, my GitHub page, LinkedIn page. I'm on GitHub. You could always find me. Ian, if you want to post like a LinkedIn link anywhere in the meetup, you can do that. You can also post it in the event, right?
Yeah, I
Yeah, yeah,
can. I'm not sure where I can do that. Yeah,
yeah. I think that's if you want to try to get in touch with anybody, like if you want to get in touch with Ian, I would say reach out to him on LinkedIn.
yeah,
That's like a fair way to go about it. LinkedIn's a pretty good way to reach out to me as well.
sure.
Yeah. Okay. All right. And I don't think that be it. All right. Ian, thanks again for doing this. Very helpful, especially for me. I'm also somebody learning MLflow, Databricks too, first time. Um, Also very insightful in sort of the techniques you're using also to like get like better sort of results for you in terms of like sanity checking yourself. Also like speeding up your results, right? That's something that I think people generally didn't, sorry, probably weren't even considering some of them,
Yeah,
especially with using tools like Stan. Very useful. Also, very enjoyed your talk, your slides. Also, would you be willing to share your slides, by the way?
sure. Do you want me to send that to you via email?
Yeah, yeah.
Okay. Yep. Totally can do that.
All right, and I'll make sure they're posted. We have a GitLab. We post all the slides there, so that's where it is. Okay. All right. Thanks again, guys. I'm gonna end the talk. Oh, what do we got? One more? Yeah. Thanks again. No problem. Happy to do it. And thanks again to Ian.
Of course.
Much love
Happy to
and
do it. This
thanks.
was fun.
All right.
Yeah.
All right. Thanks, guys. And then
Bye.
also, we're going to have a talk in March. Look out for it. I'll be posting about it soon.
Cool.
All right. Later, guys.
Thanks.